Assalamu alaikum everyone. This is lecture 26 for CX116 Object Oriented Programming. So let's get started. Last time we revised the usage of this Python's GUI framework tkinter from Python standard library, and in the end we were developing an application and we saw various versions, and actually our objective was to convert it to an object oriented application. So we made classes out of it, and we saw that we can even directly inherit from uh, tkinter's main classes, and we can make our life a lot easier, and we can make our code look a lot cleaner. So that's what we were doing, and at the end I uh, I talked about another version, like what we had done in that application. We created an application first in procedural way, and then we put all the code in a single class, and then we saw that instead of creating a class from scratch, we can inherit it from tk class. And in the end I told you that we can even create more than one classes. Let's suppose you want to make a main GUI class, and then another class for the widgets that you are placing within that GUI. So you can even keep them separate, and you know the more modular your application is, or more classes that you make, the more reusable they are. So today first we'll finish that leftover work, and then we'll explore a new widget called canvas, which is used for drawing lines and shapes in a window, in a GUI window. And then using this new widget, we'll develop a new application, and in which we'll try to create a line plotter, a simple line plotter. It will take input from user for a line equation, and then it will plot that line. And after that I'll show you an alternate method too. This is what we'll be doing with tkinter, but there is a built-in package also, matplotlib, for drawing 2D graph. So we'll explore that package too. So in this version 4, what I'll do, I'll create two classes. One main class for creating the main window, and that window will call or instantiate a method of another class, and that class will be responsible for placing all those sub widgets inside that main window. So let's start coding this. This is our import statement, and then this is the same. I'm importing my temp converter class from tk, so that I do not have to use that double indirection or double dot operators. It will call the initiator of its superclass first, and then I can set size of my window and title of my window. Now here is the difference. Here last time we were calling simply a method from within this class. Like last time, create converter was a method of this class temp converter, so we were calling it using that self dot operator. But now what we'll do, we'll create another class for create converter, and since that's a separate class, so if I want to use it here, I'll have to instantiate an instance of that class. So here I'm instantiating the instance of that class, and this self actually, this create converter will create some new widgets, and those widgets should be placed in this main window which I have created in this temp converter class. So if I want to place those widgets in this window, I have to pass the handler of this current window to that class. So this self, which is used as argument in create converters initiator, it will help those widgets to be placed within this main window, right? So this self is actually passed as an argument to the constructor of this class create converter, and this is the last statement, or the essential statement. Now let's come to this class create converter. Now in this class, this is my declaration for my new class create converter. Here is my initiator. Now you see that this R is the handler to the main window, which has been passed to it by temperature converter class. I hope you remember that from the previous slide, that we passed self from there, and that self is received as R here. So now this R points to the or contains information about the main window. Now the problem here is that I'll be defining more than one methods here, because I have to define a separate method for when that button is clicked. So that means at least two methods will be here. So both those methods, they require the handler to that main window. That means both of them require this R. So now I have two choices here. Either I can pass this R to those methods, which is not very appropriate because, or not very easy, because we know that we call that function using that command option. So the simplest way to use it is just to write the name of that function. We do not specify these parameters there. So the other option could be that I create a local instance variable and assign R to it. So this is what I am doing. Self.root is a local instance variable local to this class create converter, and I am assigning R to it. So now this self.root points to the main window. Remaining code remains the same. The only change is that wherever I was using root, I am now writing this self.root. So there is no change in the rest of the code. Here comes the method convert to Fahrenheit. This is also the same, except for that change, root replaced by self.root, and that's it, right? So what will happen in main program, I'll instantiate an object of temp converter type, and then temp converter is instantiating an object of create converter type. So I have successfully converted my code into two classes. I've broken it down or modularized it even further. But the problem that has come again is that of self.root, that long name that we are using. I can solve this problem, and let me show you how I can do that. Although it looks fine, but if you want to improve it even further, I have one more version for you. So now in this fifth version, the last version, this class temp converter, it remains the same. I have not changed it at all. Now let's come to the second class which I want to modify. Now what I'll do here, I'm trying to alter my create converter class. So what I was doing previously, I was creating some widgets, like I created two label widgets and a button and an entry widget, and I placed them all in the main window. Now what I will do, instead of placing them all in the main window, I'll create a frame, and I'll place all my sub widgets into that frame, and then that frame will be placed into the main window. So what are frames actually? Frames, they are kind of invisible windows, and they are used to organize widgets. For example, you have to put lots of widgets in the same window, then it might be difficult for you to place them properly. Like it's really difficult to place a lot of widgets and then position them correctly as you want there. So what you can do, you can create different frames, and then those frames can be placed in the main window. Right now you see what I'll do. So I have to create a frame. So what I'm doing here, I'll inherit my class or derive my class create converter from frame, as you can see here. Right, so frame is a built-in class in tkinter library. I'm deriving my class create converter from frame. So that means my class create converter is a frame, right? And this is its initiator. You see that R is still there. This has been passed from the previous class here, the handler, to the main window. Now, like we did in when we inherited from TK, we called the constructor of the parent class. So we'll do the same here. So here I am calling the constructor of my superclass frame, and I am passing this R, which is the handler, to the main window to it. So that means this initiator of my superclass, it will create a frame within the main window because I have passed R to it, and it will create an object of that frame, and that object of frame can be used by me in this class. And since I don't know the name of that object, so I'll use self instead of it. So now you see here I have placed self. Actually, this self refers to the frame. So that means I'm putting this label into the frame, and frame has already been placed into the main GUI window. So I'm putting label into the frame, packing it. Then I'm putting this entry widget into the frame. Self refers to that frame, and I'm packing it. Then I'm placing this button into the frame, and I'm packing it. And in the end, I'll pack the frame also, because the frame is also a widget which has to be placed into the main window. Actually, I have assigned main window to it. So this last pack statement, self.pack, is placing frame into the main window. So that's it. Similarly, when you write this second method, here also I'll use self. So self means label 2 or L2 has again been placed into the frame, and then I'm packing it. So there is no place to show you that instantiation statement from main, but it's the same as previous. Like in main program, you will create an instance of temp converter class, and that will create an instance of this class, and this class is a frame child, or is also a frame, and that's how it works. So now I have divided my program into two classes, and both the classes that I am using, they have been derived from tkinter's built-in classes. So what I have tried to show you in these 5 versions, that there are various ways of converting your application to an object-oriented application, and you can choose whichever version you are comfortable with, or whichever version suits your requirements the most. Now let's come to this canvas widget. The canvas widget is a fun widget that can display drawings consisting of lines and geometrical shapes. So basically it is used for drawings. You can draw shapes and lines by yourselves from within the program, or you can ask user to draw anything on the canvas that you create. So uh, it's fun working with this widget, but there is a package available in Python called Turtle Graphics, and that provides a much easier interface as compared to Canvas. But we'll explore this widget right now, and it will give you a fair idea of what such packages or such widgets do. This is the syntax for Canvas class. It takes 2 arguments, master, as we have discussed before as well, that this master will be the handler of the main GUI window. So or the window where you want to place your canvas. It could be a frame, it could be another window, or it could be your main GUI window. And then you can specify a number of options also to customize the look and feel of that canvas. So basically this statement will construct a canvas called my canvas. My canvas is the object that will be created, and its master will be this master object, right? Now here are some options that can be used to customize canvas. These were some options that we saw before in last lecture, so they apply to canvas as well. And here are some new options. Again, I'm giving you the list. I won't go through these options one by one, but they are just for your quick reference if you want to use them. Similarly, here is a list of some methods supported on this class canvas. These were the ones that we have already discussed before. These apply to canvas class as well. And here are some new methods. The first one is create arc. This can be used to create an arc. And you see, we are passing 2 sets of coordinates, x0, y0, x1, y1. And how it creates the arc, it considers an imaginary square or a rectangle with top left position to be x0, y0, and bottom right to be x1, y1. And that arc is drawn within that rectangle. I'll show you an example shortly. Then you can add some options also, like you can fill your arc with some color. You can provide start and ending angles using start and extent parameters. And then there are some styling options also. Similarly, we have another method called create line. It will create a line. You can give 2 points or a series of points. It will create a line passing through all these points. And then you can create an oval similarly as you created an arc. And then here are a few more. You can create a polygon, you can create a rectangle, you can even write text in a canvas using create text method, right? So here one different option is of text. You can provide that text as option, and that will be printed in the canvas at location xy. Xy will be the position of that pixel where this text will be shown, right? And I hope you remember how x and y increase in a canvas. It's like the normal GUI window, so it's like an upside down graph, right? So top left corner is 0 0 for x and y. Now let's see a small example, a quick example, just to see how this class works, and then we'll go to a better example. Here, first I need to import some relevant classes TK and canvas, and I'm using object-oriented approach, so I'm deriving my class, my canvas, from tkinter class TK. And we know what's the format. When you're deriving from TK, you must call initiator or constructor of the superclass, which is TK in this case, right? Now I can write my own code. Here I'm creating a canvas. You see canvas is the class name. So basically this is the constructor of class canvas that we are calling. We are passing a master to it, which is the self. That means the main window. And then we are specifying width and height of our canvas, and I'm using another option here. I'm setting its background color to be blue, otherwise you won't be able to see it, because main window is of a white color, and if you are creating a canvas of white color, then it won't be visible. Okay, now here I'm creating a line. I'm specifying two sets of coordinates, so that means a line will be created starting from 10 10 position to 50 10 position. So it's going to be a straight line, and only x-axis is changing, so it's going to be a horizontal line. I'm setting a color black, and I'm setting width of the line to be 4, because if I leave it to default, that is going to be a very very thin line. Now I'm creating an arc, and see, I'm specifying some coordinate 20 20 and 100 100. This will form a rectangle, and my arc will occupy this space, this rectangle. And I'm choosing a color for my arc. I'm filling it with yellow color. Similarly, I'm creating a rectangle of red color, and then I'm writing some text. I'm writing this text Python at location 125 125. That's it. Now I'm packing my canvas to my main window, and then this is the essential statement. So actually what I did, I just created a class and I did everything in the initiator of that class. So in order to run the code, I just need to instantiate an object of that class. So here it is. My canvas was the name of my class. And if I run this, this is the output that I have created. Okay, there is a black line of width 4. Then there is a yellow arc, a red rectangle, and there you can see the text Python also written at coordinate 125 125. So it's pretty simple to use. Now let's come to another application or another better example. Now in this example, what I plan to do, I'll create a line graph plotter application. So we know the equation of line is y is equals to mx plus c. So I'll ask user to input values for m and c, and then I'll plot a line graph using those values of m and c. And here I'm fixing values for x, like I'll plot the graph for x ranging from 0 to 399. Actually these are 400 values. So what I'll do, I'll first take input from user. Obviously I'll use GUI, and I'll take these values input from user m and c, and then I'll evaluate values for y, like 400 values for y, because if I need to plot a graph, I require those values. So I have 400 values of x from 0 to 399, and I'll find out these 400 values for y using equation of line, and then we'll plot those values, and let's see what it shows. Obviously it's going to be a straight line. Let's see how we can do this. Now what I plan to do here, I'll break my code into two classes. The first class will create the main window and the second one will create the rest of the widgets, the input widgets and the canvas widget. So basically I'm taking the same approach that I took in last lecture, that comprehensive example that we did in last lecture. So here is the necessary import statement. Since I'm taking input from user, I'll be needing these widgets: label, entry, button, and frame, and then canvas, of course. Now here is my first class, main class graph plotter. I'm importing it from TK, the same method. I think I don't need to repeat it again. We are setting minimum size for it, title for it. I'm not setting maximum size here, so you just go, when you run this, you see what's the difference if I don't set a maximum size. To what maximum size your window goes when you click that resize button. Okay, now as we did in last lecture, the second class, I need to instantiate an object of that class here. So that is going to be called line graph, and I'm instantiating an object of that class, and I'm passing a handler of the current window to it, and C is that object, and this is the essential statement of main loop. Now let's come to this class line graph. Now coming to the second class, as we did before, I'm inheriting it from frame. I'll place everything in frame and then I'll place the frame in the main window. So as per rule, I need to call initiator of the superclass frame. And now I'll do my work. First of all, what I have to do, I have to take two inputs from user, M and C. So this is an appropriate statement for label 1 equation. Okay, first of all, I'm printing some information that equation of line is y is equals to mx plus c. Now, and I'm placing it into the frame, and now I'm placing second label where I'm asking the user to enter value for m, and here is the entry widget for it, right? Then I place the second label for c, and here is the entry widget for it. Right now what I'll do, I'll place a button here, and that button will make the graph. Actually, we'll call a method that will create the actual line graph. So here's the button, and that method, I'm calling that method draw line. So I'll be implementing draw line on the next slide, and then I packed it, and then I packed the frame too. Right now let's come to the main function, which is draw line. So what I'll do here in this draw line method, in draw line method, first of all, I'll collect the values for m and c from those entry widgets, and then I'll use those values of m and c to calculate different values of y. We have already predefined a range for x from 0 to 399. That means x has 400 values, and we'll find value for y for each x. So that means I'll create a list for y, right? And I'll place those values in this list. Now this is the statement by which I can get value from that entry widget that was made for m, and I'm typecasting it to integer because that returns a string, and then I'm assigning it to m. Same is the case for c. Now here is my main loop. Here what I'm doing, I'm not creating a graph right now, but I'm just setting values for y. So the 400 values for y. Here is the statement. It's a very simple statement. I'll simply multiply m by x. X is the value on which this loop iterates. So basically it will iterate from 0 to 399, which we want actually for x. And then I'll add c. So this will evaluate to an integer value, and that value will be placed in that list y. So if you print this list y after this loop, you will see 400 values in that list y. Now we have prepared the list for y. We do not need to prepare any list for x because it's simply integer values increasing from 0 up to 399. So here I'm creating my canvas, specifying height and width to be 400. That means it's going to be a grid of 400 by 400. I'm setting the background color to be red. And here is my loop. Here what I'll do, we have seen create line method, and create line method can take an array as well, like a list of values as well. But here what I'll do, I'll plot 2 points at a time. Like first of all, I'll draw a line from x0 y0 to x1 y1, and then I'll extend that line to x1 y1 and x2 y2 and so on. So I'll do this in a loop. So this is the statement. Create line is the method, and I'm passing it the arguments x0 y0 and x1 y1. Now you see x is simple at both places, but uh, here in y I am subtracting the value from 400. Now this is because y is inverted um, in the window. As I showed you earlier, that x increases from left to right, which is okay. In graph also x increases from left to right, but in the window y increases from top to bottom, and that's not the case with graphs. In graphs y increase from bottom to top. So that's why I have to invert y, and in order to invert y, what I am doing, I am just subtracting the value of y from the total height of the canvas. And as you can see in the previous statement, we set the total height to be 400, so I'm simply subtracting the value from 400. So otherwise, if you don't do this, you will get your graph inverted. Like it will start, uh, you know, it would be like an upside down image. So here, first time x will be 0, so this is going to be x0 y0 and x1 y1. In next iteration, it's going to be x1 y1 and x2 y2 and so on. And here are some optional arguments. I'm setting line color to be black and its width to be 4, and then I pack it into the frame, and this is the statement that I'll write in the main program. Here's the output. Here I entered 2 for M and 7 for C, so this is the resulting line. It looks good, but it's not that good. Like we have not displayed any markings on the axis, labels for the axis. So let's see a better option for doing all those things. Now let's explore this package, matplotlib. And as I told you earlier, that this package is used for plotting 2D graphs. So here is a definition that I found on its official website, and see, it's huge. It's a comprehensive library for creating static, animated and interactive visualization in Python. So we won't be able to explore it completely, but I'll show you how the basic use of this package. And we'll use this package to plot the same graph which we were doing on the last slide. Like instead of using a canvas or creating my own canvas, I'll use methods of this class to plot that graph. So let's see how we can do that. I'll keep the remaining GUI same, like inputting M and C values from user and calculating Y. The only thing that is replaced here is the canvas. My canvas will be replaced by their canvas. So in order to use it, what I need to do, I first need to install this package. I've already shown you how to install a package in PyCharm. So here is a short clip for installing the same package or any package in idle. So this is the command pip install matplotlib, and you have to run it from the command prompt. Okay, now let me show you how we can install the package matplotlib here in Python idle. Last time I showed you how to install a package in PyCharm. So let's see how we can do the same thing here in idle. What you have to do when you install the package, it will appear in this folder. Like you have to go inside this folder through command line and install the package here. So you see, if I convert it to all files, see, here are some packages that I have already installed. So what I need this path. So I'll just copy it from here, and then I'll go to the command prompt. Okay, here it is. And on command prompt, there is a DOS command cd. Cd stands for change directory. So I'll write this and then I'll paste my path here. Right now, you see, I hope you guys are familiar with this command cd. This is a command line command, or you can say it's a DOS command, which is used to change directory, because currently I am in C users Maria. I want to go into this directory scripts. So that's why I have used this. Now you see I'm already in C users Maria, so I can remove this part, right? Now you see if I hit enter, now I am in the right directory scripts. Now within this directory, you just have to run that pip command, pip space install and the package name. Matplotlib, sorry, it's small, plotlib. That's it. So this is the command, you press enter and see it's installing the package. Let's wait till it's done. So see, it's so simple. You just have to run that pip command. That's all. Okay, it's taking a lot of time. 53, 54, 55. Okay, it's not done yet. Okay, now it's done, right? So this package is installed. It's asking me to upgrade something. Okay, that is absolutely fine. This package will work with the current version as well. So see, installing package was this simple. Now let's go back to the slides. Now let's use this package. I'm doing the same example as I told you. I'm just using this in place of canvas. So okay, I don't need to import canvas now, but okay, I just copy pasted it from the last code. Now here, this is my new import statement. I've already installed this package matplotlib, and I'm importing this class pyplot as plt. Or I could have written from matplotlib import pyplot. That could have worked even better. So you know there are various options of importing a class or a function from a package or a module. Now here you see this was my first class. I'm not making any change to it. This was the class that was creating the main window. So it remains unchanged. Then this class where I was creating line graph, it contained two functions, two methods actually. One was initiator method. Initiator method remains the same. I only need to change that canvas. So that should be done in that specific method. So initiator remains the same. Graph plotter class remains the same. We are changing this method only, draw line. Now here, what I need to do, using this matplotlib package is really easy. There is a method here which plots a graph, a line graph, or any kind of graph that you want. You just need to pass it two lists. One list for x-axis values and the other for y-axis values. So we had been calculating y-axis values previously as well, but this time one more thing that we need to do is that we have to place values of x also in a separate list. So therefore I am initializing an empty list for x, an empty list for y. I am obtaining these values from those entry widgets. Actually, the input mechanism is the same GUI. So I'll be obtaining these values from these entry widgets. And here is the loop that was creating values for y or filling that y list. And within this loop, I'll work for x as well as y. So you see, I have changed just that name. Now the loop iterator is I instead of x. And in x list, what I'm doing, I'm simply appending y. So that will create a list of integers starting from 0 up to 399, and y will have the corresponding values calculated through this line equation. So this is pretty simple. I hope there is nothing difficult here. Now, you see, when I come out of this loop, I'll have two lists, one for x values and another for y values. And both of these lists will contain, each of them will contain 400 entries, right? So here is the method. PLT is the class, so PLT.plot is the method. You just need to pass x and y, and x and y, these are two lists, and this will do the remaining thing. Now, this method or this class, it has some other methods also, just to improve the look and feel of your graph. So you can set label for x-axis, which I'm setting to x, label for y-axis, which I'm setting to y, and you can set a title for your graph, which is this, and that's it. And this is the command show. So once you have plotted the value using that plot method, you just need to call this show method. It will make your graph appear at the output. Now, one thing that I'll show you shortly is that this package, matplotlib, or this class PLT, it will create a new window. There is one window that I created, that main GUI window, but this will create its own window, and you'll see how better looking it is as compared to our canvas in the last example. And here's the statement which you'll write in the main program just to initialize or instantiate your graph plotter. Now here's the output. This is the first screen. I entered value for m and c. M is equals to 2 and c is equals to 8. As soon as I hit this draw line button, what it will do, it will create the graph for me. But unlike last time the graph was created within the same window because I placed the canvas here. This matplotlib package will create its own window, and here it is. And now you see here, it's much more refined as compared to our own canvas. Like, we could have done a lot of work on that canvas as well, but this is a ready-made method. It's printing those markings on x and y axis as well. It's printing labels for x and y axis, and it's printing the title for my graph. And you see there are some options near the bottom. You can even save this graph. You can enlarge it, and there are various options. You simply can try them out by yourself, right? So you just go and run this, and as a result of this code, two windows will appear. The first one where you will enter values for m and c, and the second window where this graph appears. So this was just one feature of this package, matplotlib, and the result came out to be really amazing as compared to our own graph. So, but there is a lot more to explore. So you can use these packages, and you can use the power of these packages to create really, really good outputs. And you can associate them with your GUI as well. Okay, now here's a practice task for you. Use those same methods from matplotlib package, and this time you are not going to print a line. You take custom values for x and y from users. That means that you are taking two arrays, one for x and one for y, and then you'll plot a graph using those values and just display it. So this is how it should look like. User should you are asking user to enter values for x. User enters all those values in the entry widget separated by commas, and you know how to convert this string into a list of these values. You just do that. Same you will do for y, and then you will pass both these lists to that function of matplotlib. So let's see what kind of graph it creates. And the last line is optional. If you want, you can input names for those labels also from user. So this is just a practice problem. So that's it for today. We explored this canvas widget and we explored this package, how to use this package, and we implemented a small line graph plotter application today. Thank you.